Earlier this morning, I ran a mile. My goal here was to go through the PCR and glycolysis system. Going through both of those systems in the PCR, which is also known as the phosphagen system, we're going to have phosphocreatine plus ADP. That's going to then convert into ATP and creatine. That phosphate from the phosphocreatine goes on to the ADP to make ATP. Then that creatine is by itself. Creatine stays in our muscles. We also creatine supplement. I do that as well. That's where we're going to get our creatine from. That ATP is then going to be used for energy. The phosphagen system we can only use for roughly 1 to 10 seconds, depending on couple seconds. It's going to create some potential energy. We're going to move. It's going to be used, turn into kinetic energy. Once we get out of that system, because we can't rely on that system the whole time, I ended up moving into the glycolysis system. Since I was kind of pushing myself and I was running for pace and not running for distance or running for just like comfortability, I did not leave and go to oxidative phosphorylation. I stayed in glycolysis. In glycolysis, we're going to start with a 6-carbon molecule glucose. The enzyme hexokinase is going to help us move a phosphate onto that glucose to make glucose 6-phosphate. Then we're going to isomerize that with phosphoglucoisomerase into fructose 6-phosphate. Then we're going to use the rate-limiting enzyme PFK, phosphofructokinase, to make F1,6-BP, fructose 1,6-bisphosphate, and then split that down the middle using aldolase into DHAP-G3P. That DHAP then uses TPI to turn into 2G3P. Both of those finish glycolysis, and you get 2-pyruvate.